So, hello guys, my name is Vijay. I am from Cyber Physical Systems, VIT Chennai. I am here to explain about TOC. So, here we can introduce TOC like this automata. TOC is full of automata. So, automata theory is a theoretical branch of computer science and mathematics which mainly deals with the logic of computation with respect to simple machines referred to as automata. So, in automata, we have many types like deterministic finite automata, DFA, NFA, epsilon DFA. Here in this presentation I will explain about DFA, NFA and epsilon NFA. Okay, let me go through DFA first. DFA refers to deterministic finite automata. Deterministic refers to the uniqueness of the computation. So mainly DFA refers to, like, in DFA there is only one path for specific input from the current state to the next state. So DFA does not accept the null move, that is the DFA cannot change the state without any input character. DFA can contain multiple final states. It is used in lexical analysis in compiler. So DFA is having only one path for specific input. This is the main point to remember. And let me explain about applications of DFA. DFA uses include protocol analysis, text parsing, video game character behavior, security analysis, CPU control units, natural language processing, and speech recognition. So there are lots of applications of DFA. And let me go through non-deterministic finite automata. I thought you understand DFA. So NFA stands for non-deterministic finite automata. It is easy to construct an NFA than DFA for a given regular language. The finite automata are called NFA when there exists many paths for specific input from the current state to the next state. So what is the difference between DFA and NFA? In DFA, if you in DFA we can for, for only one path for specific input. So in NFA there is multiple paths for specific input. You have to understand this. Every NFA is not DFA, but each NFA can be translated into DFA. So NFA is defined in the same way as DFA, but with the following two exceptions. It contains multiple next states and it contains epsilon transition. So let me explain the applications of non-deterministic finite automata. That means NFA. NFA used to reduce the complexity of the mathematical work required to establish many important properties in the theory of computation. So NFA is highly applicable to prove closure properties of regular languages in a much easier way compared to DFA. So there are lots of applications with respect to non-deterministic finite automata. These are the closest ones. So let me explain about epsilon non-deterministic finite automata. An epsilon non-deterministic finite automata has null or epsilon transition from one state to another. So epsilon NFA is also called as null NFA or NFA lambda. A regular expression for a language forms an epsilon NFA. So this epsilon NFA then converts to a simple NFA. We then use the simple NFA to make a deterministic finite automata. So there are lots of applications for this applications of epsilon non-deterministic finite automata NFA. So an epsilon non-deterministic finite automata has null or epsilon transition from one state to another. So an epsilon non-deterministic finite automata has null or epsilon transition from one state to another. Epsilon NFA is also called as null NFA. We can also call epsilon NFA as null NFA. A regular expression for a language forms an epsilon NFA. This epsilon NFA then converts to a simple NFA. This is very simple, you can understand. So this is the login process of some to check whether the password is correct or not. So here we'll start with some character and here I explained with the passwords. So we have here the question is to we have to explain whether the password is correct or not. So if password may be correct or wrong, with this DFA you can explain whether the password is correct or not. So like this, so many applications. So there are lots of difference between NFA and DFA. Here I point out some points. So DFA, for each symbolic representation of the alphabet, there is only one state transition in DFA. If you go back, I said that DFA having only one state transition in one state transition. So no need in NFA. There is no need to specify how does the NFA react according to the some symbols. Okay, DFA can't use empty string transition. This is very important to note. DFA can't use empty string transition. DFA can be understood as one machine. So NFA, let us see the differentiations of NFA. No need to specify how does the NFA react according to some symbols. NFA can use empty string transitions. NFA can be understood as multiple little machines computation at the same time. So NFA is very preferable as compared to DFA. It having lot of applications. So in DFA rejects the string in case it terminates in a state that is different from the accepting state. So DFA requires more space from this. We will conclude that DFA requires more space. NFA requires less space because NFA rejects the string in the event of all branches dying or refusing the string. Okay, let us go to applications of finite automated networking, internet protocol, TCP as a DFA. So there are a lot of applications of these DFA, NFA and epsilon DFA. We will see some applications of finite automata in networking, internet protocols. Internet protocol also lend themselves to description as DFA. The state diagram below represents a simplified version of the TCP. You can check here a transition control protocol. So the state machine describes the life stages of TCP connection. A connection between two computers begins in the closed state following a series of signals described by the transition arcs. So there are lots of applications, you can go through it in this PPT. There are lots of applications I point out here. This is some of the application. So there are lots of applications like this, you can go through it. And applications of the finite automata in networking protocols, internet protocol is mainly I focused on this PPT. You can go through it. I written everything. So this is the difference between DFA, NFA and epsilon NFA. Okay, thank you guys.